Hey everyone, thanks so much for joining us today. I'm Pranil, founder of Augur. At Augur, we're focused on helping organizations actually deploy AI in production, not just run pilots. So we're really excited to dive into some research that came out of OpenAI recently that Adi and I were talking about over the weekend. Hey Adi.
Hey, Pranal, I'm super excited to be doing this. I'm glad we went from a weekend of discussing this to all right. Let's put this out there, right? Hello, everyone. My name is Adi. I'm based in New York. I spent close to 2 decades in the technology space globally. My day job, I lead AI initiatives at Google. Spend a lot of time thinking about what it takes to get AI working reliably in a real enterprise environment. I have to clarify I'm here today in a personal capacity. So everything we discussed remains my views and not those of my employer. That being said, we've got this public paper, and it's an awesome opportunity to have a deep discussion with an amazing colleague and friend. So let's jump straight into it. A forewarning: I think what we're going to share today it's exciting, but also sobering and clarifying.
Absolutely. Right. So let's jump in. So we're going to talk about GDPval. And what's GDPval, right? So GDPval is a data set. It's a new benchmark released by OpenAI to measure how well AI models perform on real world, economically valuable professional tasks. So unlike traditional academic tests, like GDPval focuses on the knowledge work that contributes to countries' GDP. So the scope here is pretty remarkable. So 44 different occupations across 9 GDP sectors. So we're talking about over 1,320 tasks total, with 220 of them open sourced. So researchers can actually validate the stuff. And crucially, these aren't just random occupations. These were handpicked. They are the 5 highest earning digital occupations in each sector. So collectively, we're talking about $3 trillion in wages. So now, what makes this different from someone just making up tasks, right? So the key difference is the creators. So these are experts with an average of 14 years of experience. We're talking people from companies like Goldman Sachs, Meta, Microsoft, JP Morgan, Boeing. So not junior folks who are just joining the workforce, but actual senior practitioners and the tasks that they created. So the average task represents about like uh, something worth like $400 of real work, roughly 7 hours of the effort, right? So these went through multiple expert review rounds when you look at these evals and these tasks. So Adi, you looked at a lot of benchmarks. So what makes this one different from your perspective?
Yeah, and we'll get into, I think, hopefully a lot more detail on that. But the key note here at this stage is that this is about economic grounding, right? So, most benchmarks today that we use to talk about things like, is the AI smart? Did it retrieve the right value? Did it summarize a blob of text correctly? This particular paper talks about, hey, did the AI create economic value in this task? Right. This sounds sort of similar. It sounds like a linkage, but actually, this is fundamentally different if you think about it. They also validated this against economic frameworks. So all of this task classification that they looked at was what typically people would call deeply cognitive work. This is the stuff that was really, really hard to automate, right? In the past, those of us who worked in RPA would know. So in that sense, we're not testing AI on toy problems. This is like testing on real intellectual work that experts in each of those fields would do, and you would grade that.
Exactly. And that brings us to what they found, right? So the headline number, it says roughly 48% win rate. Now what does that mean? So it means that half of these tasks, the AI performed as well or even better than the human expert who performed the task. Now, I want to be clear what this is and isn't. This isn't about AI being 48% as good as an expert in that domain. This is AI winning outright in 48% of all the cases. And that's a big deal. So we are clearly at an inflection point here. So Adi, you talk to enterprises about AI readiness all the time. So what does this number mean to you?
Yeah, and the most interesting thing, especially in the climate where where we talk about the trough of disillusionment and the slope of enlightenment, right? The reality is that this is an amazing result, right? This is past the point where people can say we just wait this out. This means that 48% of the time the AI model does better than a human expert on what is actually a deeply intellectual task that somebody with 10 to 14 years of experience in that field would do, right? So we have to recognize what this is. And from an enterprise standpoint, I think every enterprise needs to figure out, hey, what can we do to increase our learning rate on this new technology? And how can we sort of generate value from this? There's also some interesting things, and we'll dig into that slightly later. The performance varies by occupation. uh, what most of the people in our circle wouldn't want to know, Pranil, right, is that the software development tasks here, they saw AI do the best, right, over the experts. And but it also did that for financial analysts, and we'll dig into that a little bit. And interestingly, on subjective judgmental tasks, for example, there was this one example of directors and producers. The experts did a lot better. And so we can't just say that AI can do all knowledge work. I think we need to get a little more nuanced into it and say what sort of work can AI do really well. And we know that it does a lot of that really well. And so, given that, let's dig into some sort of specifics, right? In terms of what is some of these GDPval data sets sort of going to look like. I know we dug into that a little bit, Pranil, and so we should sort of talk about this in a bit more detail. Let's give folks a flavor of what this includes. So let's look at the prompt. We're looking at sort of the open source data set that was released as part of the paper. And here's one prompt. This prompt is in the category of accountants and auditors. And it says you're an auditor and you're part of an audit engagement, and you're tasked with reviewing and testing the accuracy of reported anti-financial crime risk metrics. And in the prompt, it says there's an attached spreadsheet titled population, and we look at that spreadsheet in a second. It contains these metrics for Q2 and Q3. And then the prompt goes on to say, using the data in the population spreadsheet, calculate the following: calculate a required sample size for audit testing based on a 90% confidence threshold, perform a variance analysis, select a sample for audit testing. So it gets into a fair amount of detail that a typical forensic auditor or a financial auditor would do. And then it says, create a new spreadsheet titled sample. So that's the output with two tabs with a certain amount of detail and analysis. And just for clarity, let's take a look at sort of the actual spreadsheet for this. It actually has about 7 or 8 columns, which talks about by country, by metric, and a Q2, Q3 data. I think what I want to sort of ground ourselves on as we talk about this is that this is essentially a task that was asked of the AI. It's a deeply specific task for a certain role. And if you think about it, this is the prompt, and then the prompt includes that spreadsheet. So, firstly, this is incredibly detailed and complex if you think about this. The second part of this is that this is completely multimodal, right? You're giving it spreadsheets. In some cases, you're giving it CAD documents, presentations. So there's all of those requirements, and the outputs are pretty specific as well. And that makes it really interesting and challenging. But it's a great grounding in terms of what this actual data set is.
And I
Pranil,
think this
of
also
course.
seems like exactly the kind of gap you are seeing in the enterprises, right? So generally, when you talk about the last part, which is the unstated expectations and the real work, right? So talk to us about the gap that you are seeing in the enterprises.
Yeah, so this is a really interesting one, right? Because what's the definition of a good enough task for something like this? It's not just an answer, it's about how that answer is presented. And in the GDPval paper, they talk about things like file formats, style guides, and they talk about whether this is compliant with that requirement or not. And experts actually ended up having to review this. So the really interesting part about this is that it's the what, it's the how, and the whole thing ends up becoming like some sort of a quality metric of, hey, is this good enough to be part of my enterprise? that's a really interesting, deeper insight there.
Understood. And that also brings us to maybe the most important finding in the whole paper, right? So so here's what it gets where it gets really interesting. Evaluating these tasks is hard. The human grading takes over an hour per task, and when you have two human experts grade the same task, they agree 71% of the time. So there's inherent subjectivity. 71% means there's inherent subjectivity, right? And the researchers want to automate this. So they've built an automated grader. Think of it like an LLM as a judge, and they threw massive resources at it. So using GPT 4.0, which is the best model available, and they got to 66% agreement with human graders. Now 66%. So that means in a third of cases, the automated grader is getting it wrong, either saying something is good when it's not, or it's saying it's bad when it's actually fine. So I think talk about what this means for a typical enterprise.
Yeah, this is sort of a fascinating thing to dig into. I think number one is that if you look at sort of how this entire uh, analysis is laid out, the first principles are the same, right, in any enterprise. So even here, you had a prompt, you had some amount of context engineering. So you gave it like a spreadsheet, and asked the model to do a task, or the Gen AI app to do a task. You had evals, you had a golden set, you had an autorator or an LLM judge, and you had human annotators. So if you take these piece parts, these exist for every single use case out there. Even a regular enterprise trying to do this, any startup trying to implement Gen AI is having to deal with each of these. I think the wake up call here is that if you look at a task of this nature, which is deeply economically valuable, highly cognitive, uh, a large lab could only get to 66% on what's essentially an auto rating model. So when you break it down to an enterprise, right, you don't have this sort of scale, and this is a company with unlimited scale that is at this level. So I think the notion of an enterprise trying to do Gen AI, one of the most important things is how do you validate that this is good enough, and how do you validate that you're ready to sort of scale this. Companies routinely think that here's a pilot, I'll just scale the pilot by adding more code. That just does not work. This is hard. Validation is hard. It needs domain experts. It needs a structured guardrail process, which we'll sort of really get into. It's not just better prompts. It's really the whole infrastructure and scaffolding around it. And that, I think, Pranil, is sort of one of the most important takeaways from this.
Yeah, and when you look at where the model actually fails, it's not what you'd expect, right?
Yeah, that's another sort of interesting one, and like let's see if we can sort of look at the paper itself a little bit. And I'm not too sure if the font's really readable. Maybe folks would have to zoom in on this, but the paper actually has an appendix that talks about win rates by occupation. And one of the things you'll see there is, things like software engineering, most models do really, really well. Things like directors and producers, purely creative tasks, they don't. So wherever there's objective uh, scoring that is possible, or any objective criteria, these things worked really, really well. Then there is also things about where the answer was right, but not in the right format. Like it wasn't in the exact spreadsheet or the PDF format that was specified in the model. And there is judgment there. And in an expert use case, that judgment is really important. We expect that of experts in a company, being able to deliver an output. So that led to certain failure modes as well. And Pranil, some of those failure modes are really interesting as well when we read the paper, right?
No, absolutely. I think so. This is key. Like 47% of failures were rated as acceptable but subpar. So only 3% were catastrophic. So what that means is most of the times when AI fails, it doesn't just randomly produce garbage. It produces something that's still fine. It's usable, just not as good as the expert would have done, right? So, and that's actually pretty hard to deal with than the catastrophic failures. If something is like failing fast, you have like a ways to kind of handle it in an elegant way. But if it is failing in a very, very subtle way, spotting mediocrity is super hard, right? You need judgment to spot it, and that's expensive. Which, yeah. So, any thoughts
Yeah.
there?
Yeah, oh, that is so fascinating because I was sort of fixated on the 3% catastrophic number, and then the point that you're making around, hey, there's a 20% in between that's considered bad. Figuring out what is bad, that is really really hard, right? And that's where I guess it comes to sort of the next question and the real question for an enterprise, right? Which is that it's no longer about can AI do this job. That's really the wrong framing of the question. And you go hunt around and saying, do I have a use case for AI, and can AI do this? I think it's sort of validated in multiple different ways now that that is the wrong framing. The real framing is, can AI meet our quality standards as an enterprise? Which also means, can we detect it when it does it, right? And that's sort of so important. This is sort of the nuance that enterprises miss, which is that you do a pilot, it works really well, everybody's excited, and they say, great, let's scale it. And they scale it, they're starting to get quality issues, multiple teams are crawling out of the woodworks, and end users are upset, you have to do redo work, and dealing with all of this in production at scale is really really expensive, which is not in the case in a pilot. And Pranil, I know you thought deeply about sort of what it takes to address some of this.
Exactly. So I think I've been thinking a lot about this. So it's interesting, like because detection of failures is it requires infrastructure. So you need evaluation systems, you need feedback loops, you need constant monitoring of both user behavior and their interactions with the agent, and you need a way to route edge cases, like where the agents are failing, and how do you kind of get that audited by humans, right? And you need ways to learn from failures and improve. And so this isn't just solved by like writing better prompts, right? So better prompts help, but they don't solve the fundamental problem of how do we know if this is good enough, right? And that's what many app developers, agentic app developers, are potentially like underestimating. Like when you put it in production, thousands of users. So how do you kind of scale this as a process, right? And they think that the technology is the hard part. However, the technology is the easy part. It's the process and the infrastructure which is the hard part here.
Yeah, we all sort of get paid to solve the boring problems sometimes, but the boring problems are like some of the most important things out there, right? And this sort of brings us to the whole thing about prompt optimization. And Pranil, you want to talk about this?
Yeah. Okay. So the researchers try to optimize performance. So they got like 5 percentage points of improvement. So think of it like 5 percentage points. That sounds meaningful, right? But when they looked at what it took to get to that 5 percentage points, they had to render files as images because the models handle images better than like native file formats. I mean, they had to do a bunch of the other things too, right? Like they used best of four sampling, meaning they generated four responses and picked the best one, right? And then they used a separate judge model to select the best response. And they implemented pre-submission checklists. So think of it, right? This is multiple things to be done to get a 5 percentage point improvement. So this isn't just like prompt engineering. So this is building production infrastructure and the process. And it's expensive. Think of it like best of four sampling means you're paying 4x the inference cost. You need a whole pipeline with multiple model calling, file rendering systems, judging logic, and all. Right. So Adi, this is where enterprises get stuck, right? They think that prompts are the right path to production. So any thoughts there?
Yeah, this is sort of where I'd go back to my previous statement where I said, hey, the first principles are the same. Under you have the prompts, you have the evals, the golden sets, and you have the human annotation. How hard can it be? But this is sort of the pilot trap, right? Because teams think, hey, we'll just iterate on prompts and get to production. And look, prompt engineering helps, obviously, right? We do that all the time. But really what you need to be able to do this in a systematic, rigorous way is everything else around it, like you pointed out, Pranil, right? You need eval infrastructure. You need a whole process to be able to do this. You need quality monitoring, where you know whether the system is performant, whether it's working well in production. You have this whole notion of feedback loops, which is to take these signals and drive those into actionable insights. You need governance frameworks, because think about this. There are multiple different roles in an enterprise doing this. The quality teams are different from the security teams, are different from the dev teams, from the business or the domain teams. You need very, very systematic testing. It's not a random walk in the park, so to say, right? I need a clear view so that devs can sort of calibrate their efforts. You need failure detection on this. Things like, hey, did it just fail because I changed the model and I don't have the quota or the capacity? And you need a whole human in the loop routing process that's efficient, because in this paper, for instance, these are all experts in their fields. They're really expensive from a time standpoint. So how do you sort of make sure that you're doing this at scale judiciously is super, super important. And I think most enterprises think sometimes that why does it take so long to go from pilot to production? And I sometimes think that there is a learning effect involved, which is the first time you try to do this, you are going to take the 3-4 months. You're going to have the battle scars from this, and that is non-negotiable. That is part of the learning. And as you sort of keep doing this and keep solving different problems, this could potentially shrink to a couple of weeks. But the first time, be prepared for that hairy ride, because you're going to be creating sort of all of these processes. And I think, Pranil, that sort of brings us to the next one, doesn't it?
Absolutely. And I think that's where we need a different framework to think about this, right? And so we started thinking about what we call as like impact engineering. So it's not just AI that works, but AI that delivers measurable business value repeatedly. And the keyword is repeatedly. Anyone can get AI to work once. Getting it to work reliably day after day, handling edge cases gracefully, maintaining quality standards, that's the challenge. So, impact engineering is about building the systems that make AI reliable enough to trust with production work while ensuring that AI is aligned towards business goals and delivers impact. Right. So, Adi, what does this actually look like in practice?
Yeah, so let's sort of turn this into 5 things, 5 actionable things. I think one is, what is your evaluation infrastructure? And this is the whole kit and caboodle, right? So what's your golden set? What is your definition of success around it? How do you sort of bring data in and bring data out? And what's the human in the loop there? The second one is all of your quality monitoring systems. You need to have a really good view, for example, on if there was a failure mode, did it fail because of the system hallucinating or because of something that happened in a trace or a trajectory. The third thing is really feedback loops that work. This is incredibly hard. Uh, my tip on this is that if you feel like you're solving the same problem Friday that you were solving on Monday, you have a feedback loop that does not work, right? Because you're not learning. So you need to have feedback loops that work, that sort of compound over time. The fourth one is governance frameworks. This is incredibly important, because think about this. A dev does not decide what's part of the golden set. That's decided by business or a domain expert. And having that in a systematic governance framework is super important. And finally, how are you sort of tying this in with business value? Are you measuring the right things? And is all of this quality hill climbing that you're doing actually moving the needle on the business value, or should you have focused on something else to sort of get there? And I think that this makes a difference between sort of what's basically tinkering and what, Pranil, you were calling as a larger impact engineering, right? Because that's sort of really, really important.
That makes a ton of sense, Adi. So, like, what does it mean concretely, right?
Yeah, and I think that this is sort of interesting, right? So what does this mean for an enterprise? When we look at this paper, and for those who haven't sort of read it, it's a nice little read. I do strongly recommend that. So what should you take away? So Pranil, you want to talk about the first one?
Yeah. So, point one is about It's basically about measuring the pilot to a production gap, right? When you pilot AI in a controlled environment, the stakes are low. You can cherry pick examples. You can have humans review everything, right? But for frontier models at 48% performance, that means that even the best AI needs production infrastructure to be reliable. So you can't just scale your pilot. You have to build systems. So that gap between it worked in pilot and it works in production, that's what most AI initiatives, that's where they're dying right now.
Yeah, and I think that's where all of the research reports from my alma mater, MIT, kind of came up with one of these that talked about projects stuck in the pilot stage. Point two is sort of related and sort of an extension to that, right? You know, AI readiness is actually organizational capability. So everything that we talked about earlier, that is, how do you evaluate quality? Can you capture feedback? How do you iterate systematically? So this is the whole people, processes, and technology piece on how you can sort of build AI. And that machine and that culture is really important if you want to sort of take AI from pilot to production. Uh, Technical architecture, Pranil, you want to talk about that?
Yeah. So I think in terms of technical architecture, it really matters, right? So how do you architect your core infrastructure, then your agents? Are you doing single agent, multiple agents, and then where do you, even from an SDLC, if you think of SDLC, it's now called agent development lifecycle. That is the term that is now picking up. Where do you set up your different subsystems, and how do they interact? I think those parts, like where do you store your prompts? Do you version them? Then MCP protocols for tools use, and like file access, file handling systems that preserve formatting and metadata, and then multimodal pipelines that can process different content types, right? And things like even validators. How do you check that what is coming out of the model, is it compliant with your business policies, right? So this infrastructure, there's a fair amount of like infrastructure that needs to be put in place, and that work isn't really glamorous. So it's very different from, oh, you know what, we've trained a custom model, that's super exciting when you say that, but it's actually takes a lot of work to make AI in practice, or make AI work in practice, right? And this real work has complexity, and your systems need to handle that complexity.
Yeah, I think this whole notion, this is the really, really important work. Some of it may seem like, hey, this doesn't have the pizzazz of saying I've trained a custom model, but this is the stuff that really moves the needle from a business standpoint. And I guess that brings us to sort of the other aspect of this, which is what's the AI augmentation with accountability that we sort of saw in the paper. And the method that they used, and some enterprises do use the same method, is basically a human augmentation method, which is you use the model, you get an output, you do an expert review of that output, and you fix if needed, right? So this is sort of the practical model. You could think about using this for any AI project. To start with, bootstrap your golden set, right? Generate generate a data set, use an expert to sort of review it, and that becomes your first one. So, because using AI to do the first draft is fast, it's cheap, and then you have the expert to review it. The expert has the context. The expert can come in and say, you know what, we wouldn't consume this in this format or in this way, or this is the logical flow. And all of us who prompted like our choice of personal AI assistants has almost always has to teach them that, right? So experts can spot those subtle failures and fix them. This is way faster than sort of bringing an expert in the room in the beginning saying, tell me what good looks like. So Pranil, in a sense, it's about saying, how do we most effectively use our most scarce resource, which is our humans and our experts, right?
No, exactly. I think fundamentally it's not about humans or AI. It's pretty clear that you need humans and AI, but where, right? So where do you bring them? At what time do you bring them so that you are able to scale this efficiently? So you put AI. So here is one way to think about it, right? So you can put AI where it's good at, which is generating first drafts, processing structured data, handling routine variations, right? You put, on the other hand, you put humans where they are good at, which is subjective judgment, catching subtle errors, and then handling edge cases. And critically, so you need to build systems that route work intelligently. So how do you bring the human in the loop into the loop at the right places, and how do you kind of make them work in tandem with AI, right? And most tasks, for example, most tasks could go straight through, right? Like the AI is able to manage them, but some can get flagged for human review, and the systems can learn over time which kind of tasks need human attention. So that's not like full automation, but it's not the status quo either. It's somewhat like a hybrid model that actually works.
Yeah, and we need those hybrid models if we have to really scale this across multiple use cases in the enterprise. So, yeah, the bigger picture, Pranay.
Yeah. So the bigger picture, right, which is AI is approaching human expert capability on real work. It's pretty clear. So we are at this inflection point, which is very exciting. But this is a big but too, right? It reveals how much infrastructure work is needed for reliable deployment. So the gap between AI can do this and we can deploy AI to do this reliably is still quite large. And here's the thing. So if your organization is solving the same problems that OpenAI is solving, the validation problem, the quality monitoring problem, the failure detection problem, so you're just solving them with a fraction of the resources, right? And Adi, like what does this mean for how organizations should be thinking?
Yeah, I want to frame this as, what's the AI native way of going about building an agentic app, right? And at a very fundamental level or a first principles level, we need to think about this in two layers. What's the AI native way of building software? These are probabilistic tools. In the past, we had determinism. We knew what would happen when we wrote a piece of code. Here, the outcome is going to be probabilistic. So we need to build sort of the whole SDLC for what probabilistic looks like. And how do we sort of measure the definition of good, and how do you sort of measure how that scales? And so that is sort of really important because that gives us the taxonomy to deal with all the other problems out there. The second level of being AI native is actually a business context problem. It's a bit like if you're building a customer service agent, think about this. You today have maybe thousands of human experts. What if you had a million human experts to talk to each one of your million customers, right? With deep personalization. That's the power AI gives you. So if you were to design for an AI native world, you should think about, hey, how would I do this if I had a million customer service reps? How would I do this if I had, for example, financial analysts, again, of similar scale? So would I be able to analyze every single one of my suppliers as part of my supply chain? So use an AI native approach to significantly rethink how you would run your business processes, and that sort of will work back to a dramatically different experience. So, Pranil, some final thoughts on this?
Yeah, no, I think the final thought here is real data sets like GDPval show us what production ready actually means. And it's not like benchmark scores. It's not about the impressive demos either. It's about reliably meeting quality standards on real work day after day. That's the bar. And most organizations are not measuring against that bar yet, but they need to start.
Yeah, you're so right. It's actually day after day, every day, right? That's sort of the pace of quality hill climbing. All right, key takeaways. Pranal, you want to do the first one?
Sure, for sure. So, number one is real work is complex. The key takeaway here is like, when you think of it, it's multimodal, multi-file, and involves subjective judgment. If you are evaluating AI on simple tasks, you're not evaluating the thing that matters.
Yeah, and I think the second one is something we spoke about a fair bit, but evaluation is foundational, and companies will have to sort of bake that in on day one. Automated grading can help, and we've all seen multiple models of this. But please note, it still means that you need some amount of human annotation and how we can be judicious about it. But this notion of building evaluations as a cohesive fundamental framework for every one of your AI use cases is super important, because also think about it. Evals are actually the codification of your business logic. And when you view it from that perspective, it becomes so much more important.
Right. Right. And the third one here to add is right. The prompt engineering is not a path to production. Prompt engineering helps, but production requires comprehensive processes and infrastructure, right? From evaluation, monitoring, feedback loops, governance, all of it.
And lastly, it's all about capability building, like we spoke about. Like getting access to a model or doing a pilot is step one. Organizational maturity is step two to pretty much infinity, hour by hour and day by day. That requires a lot of work. So that's sort of our last takeaway from this. Pranil, bring us home.
Yeah, no, thank you so much for joining us today. I hope you enjoyed this conversation. The technical insights here are like, some of these are this is some of the most rigorous research on real world AI capabilities that exist. So I would encourage any enterprise which is foraying, which every enterprise today is thinking about it, but take this research really seriously, right? Anything to add here, Adi?
Yeah, and look, from a business perspective, I think this is sort of the work. This is representative of the work that everybody has to do. If you have to go from pilots to production, so start building that infrastructure, start building all of the scaffolding around it, and yeah, it's super interesting to see sort of how that scales from summarizing a blob of text to doing something that's deeply cognitive work like this. Pranil, by the way, thank you so much for inviting me on this. This was super interesting. I think we should do more of this. Maybe invite some people and chat. Weekend chats could lead to something like this. It's pretty cool.
Oh, absolutely. We should do more of this. We're both happy to continue conversations, either one on one, if folks want to go deeper on any of this. And we look forward to having more of these sessions with more practitioners in this space. And this is AI is not going anywhere. So we think it's the thing for the next decade. So I hope that you all get to have more of these conversations. All right. Thank you.
Thank you.